Now we need some examples for groups. So the simplest example is the trivial group. Where the set has just one element. And since there has to be an identity element, we call it E. And then the property of the identity says that E times E has to be E, and that fixes the group. Now another nice example for a group would be, say, the integers, and as operation we take addition. Now the identity element would be the number 0, because if we add 0 to any number, we get back this number. And the inverse for an integer a, the inverse would be just the number minus a, because if we add minus 5 and 5, we get 0. Similarly, this would also work for, say, the reals and addition, or the complex numbers and addition. Multiplication can also use for defining groups. Let's consider the real numbers, but remove 0, and then say the group operation is multiplication. Now the identity element is 1, because multiplying any number with 1 gives us back this number. And for a real number x, its inverse would be just 1 over x, because 1 over x times x is 1. And that also works for, say, the complex numbers, minus 0 and multiplication. Oh, and you see why we had to remove 0 here, because otherwise 0 would have been an element without an inverse, and that's not allowed for a group.